Hi, welcome to my YouTube channel. Today we are going to write knapsack algorithm in Python by using dynamic programming. So let's start. I'm starting with defining my function knapsack 0 or 1, and inside of my function I'm sending three different parameters. The first one will be the list of values, the second one will be the list of weights, and the third one will be the capacity of my knapsack. And in the beginning, I'm going to initialize my table, which we are calling as DP. I'm going to fill it with all zeros in the beginning. So for each row, the rows are the lists I am defining inside of the outer lists. 0 for W in range. Actually, we don't need to say range because the capacity is already an integer, so capacity plus 1. And I will create this list for each item, which means for E in range of values plus 1. Why I am saying plus 1? Because as you remember, the first row in our DP table is indicating the 0 item, which is a special case we are using in order to initialize our table. We are going to fill it with all zeros. Now I'm going to loop through to each different item for E in range. And as you remember, we have already filled the first row, so we don't need to loop through it again. So I'm directly starting with the first item, range values plus 1. And for each item, I should look for each different capacity. So for W in range, I will also start from 1 because, as you remember, when the capacity is 0, we can't add any item. So the value is going to be directly 0. So it will loop through 1 up to capacity plus 1. I am writing plus 1 because range function in Python is producing an array from the first parameter up to but not including the second parameter. So if the second parameter is capacity, it is going to produce a list which will include all the item from the beginning up to but not including the capacity. So in order to include the capacity, I should say capacity plus 1. And I'm going to check if the current item weights is greater than the current capacity. If it is the case, then that means the item is too heavy to fit at capacity W. So that means we can't take it. So in this case, we are taking the last row, the previous row, at the same capacity level. However, if it is not the case, if the item can fit, then we should look if taking that item is profitable. If it is, then we are going to take it. If it is not profitable, then we are going to take the previous row. So I'm going to write the same exact statement that we used in our example. -1 W, and in the case of taking it, -1. If we are taking this item, then its values, which corresponds here, plus the best profit for the remaining capacity after we extract the weight of the current item. So yes, and at the end of the day, after filling all the table we are going to return the cell at the last row and at the last column. So return dp -1 -1. By the way, -1 means that return me the last item. So instead of writing the exact index of the last item, you can say -1. Python is going to understand that you want the last item. So you can directly use -1. Instead of looking at backtracing in a different flow, I'm going to call it directly inside of my knapsack algorithm. So I will say my items will be returned by backtrace function. And inside of my backtrace function, I will send my DP table and the weights of my items. And at the end of the knapsack, I will also return the selected items. Now that we have completed the knapsack function, we can implement the backtracing algorithm. Backtrace, as I said, as a parameter, it will take the DP table and the weights of the items. We could also say capacity here. However, we can find the capacity from our DP table. Why? Because as you remember, the column of the DP table is actually showing the capacity. So we don't need to take the capacity as a parameter. And the capacity is going to be actually the length of the row of my table -1, because we are using zero-based array. And I is going to be the index of the items, and it will be the length of the DP -1. I will also initialize my array, which will hold my selected items. And at the end, I will return my best array. As you remember, we started at the last column and at the last row, and gradually we go up. If we take an item, then in that case, we subtract that item weight from the current capacity, and we do that until the capacity is 0. So I will say that until the capacity is 0, actually I will say as long as the capacity is greater than 0, and as long as I is greater than 1, and look if the upper row and the current row is different. If they are different. If they are different, then in that case, that means that we are taking this item. So I am adding my item into my list, and I am subtracting that item's weight from my capacity. Okay. Actually, it will be I, not I -1. Okay. And in either case, whether or not they are different or they are not different, we will decrease the I, the index of the row, because we will always look if the previous row is different. If it is, then that means that we are adding that item. However, if it is not, we are directly passing it. We don't do anything. So, is there anything left? I don't think so. Okay, now I think we can test our function. Knapsack 01, and Actually, I'm going to use the exact same values, weights and capacity that we used in our example. So let me write it. 5, 15. It is the list of values. 6, 18 and 3. And the list of weights. 2, 3, 5, 7, 1, 4 and 1. And in our example we used 7 as our capacity, so I'm also using 7. So let's run it. Oh, I think something is wrong because it is running forever. Oh, this should be greater than or equal to 1, because if I is 1, then we should also look the previous row. As you remember, Python has 0-based arrays, so there is also index 0. So I think it is going to work. Let's see. Yes. And this was the result that we reached in our previous lecture. By using these items, these are the items values and these are the weights, and this is the restricted capacity. By using this, the maximum profit that we can reach is 34. And in order to reach that profit, we should use these items, the 6, 5 and 1. So this is correct. Actually, let's walk through what we have done. First of all, we build a table, and rows are items and columns are capacities here. And at each cell, if the item is too heavy, we are copying the value from above, and otherwise we are taking the maximum of skipping it or taking it. And at the end of the day, the bottom right cell is the maximum profit. Then we call the backtracing algorithm in order to take the items which we should select. In the backtrace function, we are starting the bottom right and we are moving up. And while doing that, if the value didn't change, we are skipping it. If it increased, we took that item and jump left by its weight. And at the end, we are returning the items that we have selected. Here it will be returned, and at the end of the whole function we are returning the items that we are taking from the backtrace function as well as the maximum profit, which we can see also here. And that's it for this lecture. I hope you liked it. If you have any question or if you have any suggestion, please leave a comment here, and thank you for watching. See you in the next lecture. Have a nice day.